So let's look at question 3. So this is what we've got for question 3 here. Now, this is what's called a double or a 3-part inequality. What happens whenever we multiply or divide by a negative number in an inequality? We are going to have to switch our signs, right? So we're going to have to multiply, in this case, everything by a negative 2. That way we can clear our fraction. Now, when we multiply it all by a negative 2, negative 2 times negative 1, negative and negative makes it a positive 2. We switch our inequality symbol. Those cancel, so in the middle, I'm left with an x plus 1. We switch our inequality symbol again, and negative 2 times 3, that makes it a negative 6, right? Now, what do we do? All right, we've got it all set up. So the only thing that we need to do now is move that 1 over. Now we've got 1 less than or equal to x less than or equal to, or sorry, in this case greater than or equal to, negative 6 minus 1 makes it a minus 7. Now, what we have to be careful of is when we put these on the number line. All right, so we need to make sure we put them in the correct order. We multiplied by a negative. That flipped our inequality symbols, right? So that is also going to change how they are on the number line. So negative 7 is the smaller number, so it's going on the left. Positive 1 is over here. Now, where's my answer going to be at? It's going to be in the middle. And let's remember our symbols here. Greater than or equal to, less than or equal to, brackets. Strictly less than, strictly greater than, parentheses. So which one is ours going to get? Ours is going to get square brackets. All right, so it looks like that. And then in interval notation, what would our finished answer be? Well, it would be negative 7 with parentheses, comma, 1, or sorry, with square brackets, comma, 1 with square brackets as well. But very, very important that you remember, when you put them on the number line, you may have to switch the order. So is everyone okay with that one? Does that one make sense how I solved that? Question 4, we did something similar to it in our example questions, but we're going to go ahead and look at question 4. So this is what we've got. Okay, so question 4 in your homework, 1-7, question 4. Now, what are we going to need to do? Well, we need to solve this, right? So we come up with our critical points. And I'm going to use the square root property. So I'm going to rewrite this. I'm going to box it first so I don't lose it. This is my original. I'm going to replace this with an equal sign. And this way I can solve it. Okay, how would you solve it? What technique would you use? Square root property. We've learned all the techniques and used them numerous times. Plus or minus now. And that gives me 5 plus 4x equals plus or minus 2i, right? Okay, now, what is the problem here? Can we put imaginary numbers on the number line? Can i's go on the number line? No. Okay? So this is either going to be true, meaning everything, or false, meaning nothing. So i's cannot go on the number line, so it's either true or false. Never changes. See, when we come up with these values that we find, they're where it switches from true to false. Okay, and there's no number to switch, so it's either all true or all false. What do? We check any number, and we can check 0. You can check 1, 2, it doesn't matter. We check a number, I'm going to pick 0. And we see what happens. If I plug in 0, what's going to happen here? Well, 4 times 0 is 0, right? And that gives you 5. And what do we know about 5 squared? That's 25. And is 25 larger than negative 4? Is that true or false now? That is going to be true. And if it is true, it's going to be true everywhere. So my answer for this one will be negative to positive infinity, right? And the reason for that is we can think about this too. What happens when you square any number, whether it's positive or negative? Except for 0. If you square any number besides 0, it doesn't matter what it is, it's going to come out to be positive, right? Now, are positive numbers always going to be bigger than negative 4? Yes, that's why this was true. If it was going the other way, it would be false. So the answer for 4 is going to be negative to positive infinity. Okay, now remember, just so we remember here too, negative or positive infinity, those get parentheses, right? So infinity always gets parentheses. So always with infinity symbols, use the parentheses sign, okay? Now, question 7 is just the opposite. In question 7, it's actually going to be false, and let's see why. I'm going to work this one out, but I can tell from the very beginning that this is going to be false. Now, why can I say it's going to have no solution? Let's think about the squares again. Whenever we square a negative number, what comes out from it? Positive. So square here and square here. It still stays positive, doesn't it? So this side is positive. This side is 0. Are positive numbers smaller than 0? No. That's false. So it should come out to be no solution. Now, let's check it and make sure that it makes sense, because we can check it algebraically. This is our original. This is what we're going to be checking it in, but it should be false at the very end. Everything should be false. But let's see what our two equations would look like. If I rewrite this with an equal sign, I get this. I get x squared equals 0. Okay. That's our first half. And how do you get rid of that square again? Square root, and square root of 0 is 0. So that gives you x equals 0. Now, what about the other one? Well, that is x plus 16, quantity squared equals 0. How do we get rid of that square again? Square root. We don't have to use the plus or minus because 0 doesn't even have a sign. So that's x plus 16 equals 0. So my other one I have to check is x equals a negative 16. Now, I'm going to put these on a number line, and if our assumption is correct, everything should be false. Okay, because when we square negatives, they always come out to be positive, and those positive values are always going to be bigger than 0, not smaller. So let's put these on a number line, check values, and make sure our assumption holds. So there's negative 16, and there's 0. Negative 17. How about we pick, doesn't matter here, how about we pick negative 1, that's in there. And how about we pick positive 1. So I'm going to have you pick values, and you're going to see that all of these are going to be false. It's a good practice to check them, because you're going to have to check all the others, 5 and 6 as well, and 8, 9, and 10, you'll do those today as also. So you've got to learn how to check these values. So I made my regions. Does everyone know why I got the 17? Because 17 is less than what? Negative 16. Negative 1 is in here, isn't it? That's why I picked that one. And I need a number bigger than 1, so how about we choose 0? We're going to check these in this. We're going to use x squared times x plus 16 squared is less than 0. So that's what we're going to be using to check. And we're going to plug in negative 17 first. Negative 17 plus 16, quantity squared. Okay, so what happens here? This has got to be squared. What happens when we square a negative 17? Positive, so that's a 289. Negative 17 plus 16 makes it a negative 1 squared. And when we square a negative 1, it becomes a positive. And is 289, okay, is 289, is that smaller than 0? Is that true or false? False. And it should be, because that's what we assumed it would be. Check negative 1. Negative 1 squared plus, times negative 1 plus 16 squared. Negative 1 squared is 1. Minus 1 plus 16, that's a 15 squared. And what do we know about 15 squared? Positive again. So that's 225. And is that less than 0? Is 225 smaller than 0? No, that would be false again. And what about the last one? Okay, it's also going to be false, but let's see why. If I plug that 1 in, I get 1 squared plus 1 times 16 squared. It's supposed to be smaller than 0. So 1 squared is 1. 1 plus 16 is 17. And we know that 17 squared is 289. And that also is false. So what is our answer going to be? All of it is false, so my answer should be the empty or the null set, right? And that's what we determined it would be before we even looked at these algebraically, right? We used some common sense, and that's going to be very helpful when we look at absolute values in the next section. You have to think about an absolute value and think of a square. They're very similar. They produce positive values out. So let's now go ahead and finish up this section. And the last part of this section of 1.7 is rational inequalities. And for these rational inequalities, these are fractions. So we're going to be looking at fractions, and we have a step-by-step procedure to solve these. So the first thing we do is find the numbers not in the domain. Remember, we did a lot of these in 1.6. where you had to find the numbers that wouldn't work. After you've done that, these are always going to get parentheses. Step number 2 is you replace inequality with an equal sign. So you replace that inequality with an equal sign and you solve. Step number 3 is place the numbers on a number line. And check solutions. Check regions. Sorry about that. So check regions. And then finally, your answer is the true regions. So we're going to be looking at rational inequalities, and these are our fractions. And so the first thing we're going to do is we're going to find out what number or numbers do not exist. So division by 0. Then we set it equal and we solve. And you may or you may not get an answer here. So you could or could not get an answer on the second part. You get something up here. On the second part, when you solve it, you could or could not get an answer. And it'll either be brackets or parentheses, depending upon the original inequalities. Then you place them on a number line. Numbers here. So place the numbers on the number line, and then you check our regions. And then your answer is going to be the true regions. So it's a little bit different than what we've done before. Find out what numbers give you division by 0. Find those. Then we set it equal. Try to solve it. You may or may not be able to. Put those answers on a number line and check the regions. So I'm going to look at one that's going to be very similar to question number 8 in your homework. So here's something that is very, very similar to question 8 in your homework. So this is going to be very, very similar to question 8. Different numbers. Switch the inequalities. Very, very similar. Okay, so what do we need to do first? We need to find the number or numbers that are not in the domain. So how do we handle that? Well, we set our denominator equal to 0. So x minus 10 equals 0. Because that's our denominator here, right? And then what does that give you? Yep, x equals 10. So there's one of them. And we need to make sure we keep track of that, because that's going to go on the number line in a moment. So that's step number 1. What about step number 2? We replace that inequality symbol with an equality. So that's going to be equal now to 0. And I'm going to make that 0 over 1 so we can cross multiply. So make it equal. In this case, I put 0 over 1 so I could cross multiply. 3 times 1 is 3. 0 times all of that is 0. And this one has no solution. Okay, so that one does not have a solution. So the only number that we have to check now is going to be what? 10. Now, on the next one that we'll do, you're going to get something from here. You're going to have 2 of them to check, which means 3 regions. But in this case, we only have the one number, which is 10. And we need to figure out what to check. So I'm going to check 9, and I'm going to check 11. And we'll check these, and we'll see what we get. And we're going to use 3 over x minus 10 is less than 0. So we're going to use this. So this is what we're going to use. So let's check x equals 9. So if I plug in the 9, what is that going to give me? Okay, I'm going to use this. This is going to give me 3 over 9 minus 10. 9 minus 10 is a minus 1. And 3 divided by negative 1, well, what is that? Negative 3. And is negative 3 smaller than 0? Is that true or is that false now? That would be true. So where do I shade? Well, I'm going to get the other side first, but this side is going to be true. Okay, so that one's true. Let's check the other side. The other side we're going to check has got that 11. And you have to check both sides. Don't just check one. You've got to check them both. So I'm going to plug in 11. And that's going to be 3 over 11 minus 10. Okay, 11 minus 10 is a 1, so that's 3 over 1. And is 3 over 1, is that smaller than 0 now? Nope. So that means that this half then would be false. And where do I shade? Through half. That's negative infinity, and we use a parentheses. So what does the answer look like? In interval notation, it looks like negative infinity to 10 with parentheses. Sure. Oh, sure. Yep, up here. Okay. Yep. Sorry about that. Okay. Let me see if I can't zoom out a bit so I can get the rest of it on here. Okay, make sure we can see it all. So let's talk about what we did here. Okay, so what did we do? First thing we did was we determined what number or numbers give us division by 0. And what number gave us division by 0? 10, right? Because 10 minus 10, that gives you what? 0 in the denominator, and we cannot have that. So that's where that one came from. Now, what about the other one? There may not be another number because we tried it, said equal, and we cross multiply. And can 0 equal 3? No. So that side has no solution. So the only one that we had to check was 10. And so then we took our 10, we put it on a number line. So we got 9, which is smaller, and 11, which is larger. We plugged them in, and we plugged them back into the original here. Okay, and we saw that if I use the 9, it's true. If I use the 11, it's false. So that means it's true on the left-hand side. The left-hand side goes to negative infinity. So it would be negative infinity to positive 10. Is everyone okay with that one? Now, that one only had one critical point, only one number to check on each side of it. The next one is going to be like question number 9. So we're going to try and solve this one now. And this is going to be like homework question number 9. Okay, so this is going to be very, very similar to question number 9 in your homework. So what do we need to do first? Well, the first thing that we're going to have to do is we're going to have to determine what number or numbers will not work. And so what number is not in the domain? 2. Okay, why is 2 not in the domain? Well, x minus 2 equals 0, so x equals what? 2. So that is not in the domain. That's our first number. It's going to go on the number line. And this one gets parentheses, by the way. What about the other one? What do we do to get the other one? To get the other one, okay, we replace the inequality symbol with an equals. And I'll make that 4 over 1. And now we should kind of know what to do. So what do? Cross multiply. And this one is going to give us a solution. So we have a minus 3x plus 1. That's going to equal 4 times x minus 2. So we're going to work this one out just like we've done before in the past. The 4 is going to get distributed through. And so we have a minus 3x plus 1 equals, distributing the 4 through. We've got 4x minus 8. We'll move the 4x over. Move the 1 over as well. So what does that leave me with? Okay, that leaves you now with, when you add down, a minus 7x equals now, those cancel. It looks like a minus 7, isn't it? Or sorry, minus 9. Sorry about that. Minus 9 there. And divide by your negative 7. And what's your second point going to be? Yep, positive 9 over 7. And I'll slow down a bit so we can get caught up. So do you see what we did? Now, this one has 2 of them. All right, so it's got 2 numbers that we're going to have to check, which means 3. Because you always have 1 more when you check the regions. The 2, where did that come from? That came from setting the denominator to 0. So the bottom part of that fraction was set to 0, so that gave us our 2. The other one, we replaced the inequality with an equality, cross-multiplied and solved. This one is also going to get parentheses. And why is this one going to get parentheses and not a square bracket? Because we go back up and we look, and that gives us what? Parentheses. So this is going to give us parentheses here. Now we put these on the number line. So let's put our numbers on the number line. And we may have to check a decimal. Because when we put these on the number line, we have 9/7 and we have 2. And so a number smaller than 9/7, well, that's easy, 0. A number bigger than 2, how about 3? But is there a whole number in the middle? No, but what's 9/7 as a decimal? Just to one place, just so we have an idea. Okay, 9/7 as a decimal, if we round, is going to be about 1.3. So let's pick a number between 1.3 and 2. How about 1.4? Because that's in there. Because there is no whole number in there, because that's a decimal. So we had to pick 1.4. Now we'll check these back in our original. So let's go ahead and check them in the original. So we're going to have to use now minus 3x plus 1 over x minus 2. is less than that 4. And we're going to start with 0. Okay, 0 is pretty easy to work through. Okay, and what do we have here? Well, negative 3 times 0, that's 0. Plus 1, that's 1. 0 minus 2, that's a minus 2. Bring that negative up, and we get a negative 1/2. And is negative 1/2, is that smaller than 4? True or false? It's true. That means then this region is true. Most of the time, they're going to switch back and forth, but you have to check. It should be true, false, true, but we have to check because there are cases where it deviates from that, so check each region. Now let's pick the 1.4 and check it out. Okay, so let's just use a calculator here to check this out. And let's see what we've got. So we've got a minus 3 times 1.4 plus 1. Okay, that gives me a minus 3.2 on the top and a minus 1.4 down below. Negative over negative makes that now a positive. And 3.2, divide that by 1.4. What does that come out to give you? Negative and negative makes it positive, and that's a 2 point if we round 3. We don't have to be precise on these because all we're checking is to see if it's true or false. Where did the, my mistake. Yep, you're right. I wrote something down wrong. Let me fix it. Sorry about that. I wasn't paying attention. That should be, let me write it right here. My mistake. Down below, this should be, and sorry about that, it should be 1.4 minus 2. Down below. And that, sorry about that, is going to come out to be, okay, yep, my mistake there. Sorry about that. Minus 0.6 down below, isn't it? Sorry about that. Negative and negative again still makes it positive. And now we'll divide. And it comes out to be 5.3, doesn't it? And it should be false. And sorry about that. That was my mistake there. I didn't mean to do that. But I wasn't careful because we're plugging in the 1.4. So that's going to be 1.4 minus 2. That's there. Negative divided by negative makes it a positive, and that comes out to be a 5.3 there. And that is false because it's this larger. And now the last number is 3. So we have a minus 3 times 3 plus 1 over 3 minus 2. And it should come out to be true, but let's double check and make sure. Minus 9 plus 1, that's a minus 8. 3 minus 2 is a 1. And negative 8 over 1, that makes it a negative 8. And is negative 8 smaller than 4? Yes, it is. That would be true, wouldn't it? Okay, is everyone okay with that so far? Be very careful with these signs. Remember, how do I check these when I look at this? I make sure that it's opening towards the bigger number. 4 is bigger than a negative 8, so that's true. This one is false because 4 is not bigger than 5.3. Where's my answer going to be at then? On the edges. And this is negative infinity. This is positive infinity. They get parentheses. So what does my answer look like now? In interval notation, it's negative infinity to 9/7. We use a U for union. 2 to positive infinity. And that is going to be your final finished answer there. Is everyone okay with that? So it does require a little bit of work, but you got to. Yeah, U stands for union. What you're doing is you're uniting the pieces together. So it's basically like this piece plus that piece. But we can't use a plus symbol with sets, so we have to use a U, and that represents union, putting the pieces together. Okay? There's an upside down U, which is intersection, but we don't use that in this course at all. Do what? Yes, on set notation, because these are sets. I am now going to work out question 10 from your homework, just so we have that one worked out for you. Just so we have enough time to get through 1.8. So I'm going to go ahead and work out question 10 from your homework. Okay, now, I want you to think about this one and try to see if we can get an answer without actually working it out. We should not have to work this one out because we have a square. All right? So what happens when we square any number, no matter if it's positive or negative? What comes out of a square? Positive values or 0, right? We're going to assume it's positive. So this right here has to be positive. Now, if that has to be positive, then that's 8 over a positive number, right? And 8 divided by a positive number comes out to then be what? Positive. And our positive numbers are those going to be smaller than 0. Is this true or is this false? This is false, so that means this has no solution. So you don't have to work out question 10 because you can use some critical thinking skills. And you can understand that when you square a negative, it forces it to either be positive or 0 is still 0. Now, we're going to use this a lot in the next section when we look at absolute values. Because absolute values in squares are very, very similar to each other. So you should now be able to finish 1.7, and we're now going to look at 1.8. And we should be able to get through 1.8 today. There's not a whole lot in it. And 1.8 is absolute values. We have to remember, when we have absolute values, we get two solutions. So if I gave you this, let's see what the two solutions would be. Can anyone tell me what two numbers would work here? What two numbers? Well, okay, absolute values. Now, what does an absolute value do? Let's think about an absolute value. Absolute value makes it come out to be positive, right? So, what number, if I take the absolute value of it, gives you 9? 9. Okay? Because the absolute value of 9 is what? 9. Now, the opposite of that would be a negative 9, and that also gives you 9, right? Because these are absolute value bars. And what do the absolute value bars do? Make it positive. So when we solve these out, we are going to be having to get two solutions. Does everyone see why we have the 9 and the negative 9 now? Because absolute values, there's two numbers that work for it. Because the absolute value of 9 is 9, and And the absolute value of a negative 9 is also what? 9. When we work these absolute values out, you're going to get two equations to solve. It works off of this premise. Now we're going to solve a couple of these. We'll do the equalities first, and then we'll look at the inequalities. So we're going to try to solve this absolute value. And I like to make sure you see these are absolute value bars. Okay, so this is an absolute value. Now, we should get two equations. The first equation, we just simply drop the absolute value bars. So that gives you 2x minus 1 equals 5. The other one is 2x minus 1 equals a negative 5, right? Very important here. Did I change anything inside the absolute value? No. It stayed the same. What is the only part that I changed? The number on the end, right? So that gave us two equations. Now we can solve them and get our two answers. So we add 1. And that gives me 2x equals the 6 now. We divide by our 2. And x now equals 3. So there's one solution. Repeat the process. Add the 1. 2x equals now negative 4. Divide by our 2. And our other solution is negative 2. So those are the two answers that you're going to get. You're going to get two of them, because you have two equations to solve. Where students make a mistake is you might only give me one answer. There's going to be two of them, though. Or you might change that 1 on the inside. That is negative. Did we change this at all? No, it stayed exactly the same. But sometimes students will change them and make mistakes because you think of an absolute value and you change it, but you don't. Let's try another one. This introduces another concept. When we work with these absolute values, the absolute value must be by itself on the left. So the absolute value must be alone on the left. So what needs to happen to that 3 now? To make the absolute value by itself or alone on the left, we need to move that 3 over before we do anything else. Bless you. And that gives you the 5. Okay. Why do we have to do this? Because when we go to solve these, we have to make sure that our absolute value is isolated by itself on the left-hand side. If there's a number, like in, for example, this minus 3, we had to move it over first. Make sure you do that first. Now, once you've got it moved over, now what do your two equations look like? Yep. We just drop our bars on the first one. 4x plus 1 equals 5. And we use an OR to separate them. 4x plus 1 equals a negative 5, right? And we just work these out. So move that 1 over. 4x equals 4. Divide by your 4. And x equals 1. Repeating the process on the other side. 4x equals negative 6. Divide by your 4. And reduce it down. X equals now a minus 3 halves. Do what now? Yes, both of them are going to be answers because if I plug this 1 back in, okay, 4 times 1 is 4, plus 1 is 5. The absolute value of 5 is 5. 5 minus 3 gives you 2. If you plug negative 3 halves in, if you plug negative 3 halves in, 4 times a negative 3 halves is a minus 6, plus 1 makes it a minus 5. Absolute value of a minus 5 is positive 5. 5 minus 3 again is the 2. So you get 2 solutions. Now, they can both be positive, they can both be negative, or they can be a mixture of both. So don't just think that they're both different signs. They can be the same. What about 0? Absolute value of x minus 8 equals 0. Well, 0 doesn't have a sign at all, does it? So we're only going to get one solution. And that would simply be x minus 8 equals 0, which is then x equals 8. And we only get one solution, right? Why? Because 0 does not have a sign. Normally we get 2, but this one doesn't because 0 doesn't have a sign with it at all. Before we move on to the inequalities, we need to talk about what happens when you have an absolute value equaling another absolute value. The same concept is going to work here. We need to get 2 equations. Now, what are they going to be? Well, the first one, all we do is we drop the bars again. So that is 3x minus 1 equals 5x minus 4. Okay, nothing new there. But the other one is going to be 3x minus 1 equals, I'm going to put a negative, and I'm going to use parentheses, 5x minus 4. I'm using parentheses because that negative has to be distributed through, and it has to change the signs. So let's go ahead and work these out. The left one is easy. Move the 5x over. Add the 1. And 3 minus 5 is a minus 2x. Those cancel, those cancel. A minus 4 plus 1 makes it a minus 3. Divide by a negative 2. And one solution is 3 halves. Be careful here and make sure you distribute that negative through, because that's going to change all of your signs on the right. So we need to do that. And that gives you 3x minus 1 equals a minus 5x plus 4, isn't it? They distributed it through. Now we're going to add 5x to each side and add 1 to each side. 3 and 5 makes it an 8x. The 1's cancel again. 5x's cancel. 4 plus 1 is a 5, it looks like. We'll divide by our 8. Sorry about running out of room here. But that gives you now x equals 5/8, isn't it? Is everyone okay with that so far? And if I'm going too fast, just be sure and say something, because I can slow down a bit. But do we see what we did there? Make sure you have one, you just simply drop the absolute value bars. That's easy. The other one, though, we don't just change the 5x, we put a negative in front, and we distribute it through. Very important that you distribute it through. Let's try one more of these, Then we'll look at absolute values, inequalities. Bless you. Okay, so what would we do here? Yep. We need two equations, right? What are they going to be? They are going to be 3x plus 1 equals 4x. Right? We just drop the bars. What about the other one? 3x plus 1 equals a minus 4x. Now we can solve it. Right? Very simple. Solve it. Move the 3x over. So that gives you x equals now 1. And if I'm going too fast, just be sure and say something. The other side, we move the 3x over. And that gives you a minus 7x equals 1. Divide by your negative 7. And x now equals negative 1. 7. Is everyone okay with how I did that? So when we solve these absolute values, we end up with what? Two equations, right? That's the important takeaway that we have. We have two equations, so you get two answers. When we look at the inequalities, we work them out the same way. However, we have to graph them at the end. So we have to put them on a number line. These were equalities, so they didn't have to go on the number line. Let's do some inequalities now. Okay, so let's start with this one. Now, I picked this one to reinforce a concept again. Whenever we work with these absolute values, that absolute value had better be by itself at the beginning. So before we do anything else, that 5 has to be moved over. So I'm going to go ahead now and add that 5. I'm going to make sure we know these are absolute value bars. So I always like to make them dark. You can do whatever you would like, but I always make sure I know these are absolute value bars. It's so easy to think that's a 13, so I make the bars larger. So I move that 5 over. Now we can begin work. And I'm going to put a box around this so we have it, because we're going to come back to this in a minute. We're going to have to check our solutions in this. But what we do is we get the two values again. So we solve it like it was equals. So we solve 3x plus 1 equals 9, or 3x plus 1 equals a negative 9. Okay, just like we always would before, the only difference is at the very end, it has to go on a number line, because it's an inequality. Otherwise, we solve it the same way. So we get our two numbers. So let's go ahead and do that. So we'll move that 1 over. So 3x equals 8. Divide by our 3. So 8/3 is one of them. Same thing on the other side. Move the 1 over. Okay, and that gives me 3x equals now negative 10. Divide by your 3. And so I have negative 10/3. Now, we are not done yet. Why are we not done yet? is this is an absolute value, which means we now have to put these on a number line. So here's my negative 10/3, and here is the positive 8/3. On these, we only have to check 0. We don't have to check all the regions. All we have to check is 0. So 0 is right in here, so I'm going to check that. Now, what is going to happen is these signs always switch back and forth. So it's either true, false, true, or it is false, true, false. So they always switch back and forth. So we can get by with only checking one number. And we're going to check 0 every time. So we're going to check what x equals 0 is. And we'll see if it's true or it's false. And then that's going to give us our answer. So we go back to our highlighted one, and we're going to use now to check the absolute value of 3x plus 1 is less than or equal to 9. So that's what we're going to be checking in. And we're going to check x equals 0. So all we have to check is that, because 0 is in between. And when we check that out, plug that in. 0 times 3 is 0, plus 1 is 1. Absolute value of 1 is 1. And is, in this case, 1 is 1 going to be smaller than 9? Is that true or false? Is 1 smaller than 9? That would make it true. Now, the signs always switch back and forth. So it was true in the middle. So that means the edges are going to have to be false. So where's our answer lie at now? In the middle. Brackets or parentheses here? Which one? Square brackets. And what does our answer now look like? Let's write it out in interval notation. And your answer is negative 10/3, comma, 8/3, and it gets square bracket as well. So that's going to be your final finished answer there. Let's try another one. That was less than, so let's do a greater than 3. Okay, so we're going to try and solve this one. Well, do I have to move anything around first? Nope, it's already set up. The absolute value is by itself on the left. I like to put a box around it so I can keep track of it, because that's what I'm going to check my solutions in. So I'm going to check it in that. Now, what equations do we have here? Okay, let's try to focus on what we're working on here. We're almost finished. We got probably 20 more minutes. So let's try to focus on what we've got here. Okay, what would my two equations look like? They would look like minus 2x plus 1 equals 3, or minus 2x plus 1 equals a negative 3. Finish them out. Move that 1 over. So minus 2x equals now 2. Divide by your negative 2. And that gives you x now equals negative 1. Other side is just as easy. The 1 over. Minus 2x now equals minus 4. Divide by your negative 2. And x now equals 2. I'll slow down a bit so you can get that copied down. But do you see what we did? We broke it out into the two equations. One was 3, one was the negative 3. Then we solved them out by moving things around and dividing. We got to this point. Are we done yet? No. Why not? Because it's an absolute value inequality. So now we put these on a number line. And we've got -1 and +2. I do not have to check a number from each region. All I have to check is 0. And where's 0 at? 0's in the middle. So we're going to check x equals 0 now. And we're going to use the absolute value of -2x plus 1 is greater than 3. So use that 0. And let's see what we get here. And -2 times 0 is 0, so that's gone. Plus 1 is 1. Absolute value of 1 is 1. And is 1 going to be bigger than 3? Is that true or is that false? False. Okay. Now that means now that the middle is false, right? And what does that tell me about the edges? Yep, it's either true, false, true, or it is false, true, false. They always on these absolute values switch around. Brackets or parentheses on here? Parentheses, okay. And we're going to be here and here. So negative infinity is back to the left. Positive is to the right. And so what does our answer look like now? Negative infinity to -1 with parentheses. Then we use a U that represents union, putting the pieces together. Then we have 2 to positive infinity. So that gives us now our 2 parts to that answer. Okay. Let's try another one. Bless you. And then we'll look at some special cases. Special cases are the easier ones, but we need to do one more of these, I think, at least one more. So let's try and solve this one. And again, these are not that difficult to solve as long as you remember all the steps. So first things first, what do I need to do? Yep, add the 2, right? Before we do anything else, before we even start coming up with our equations, we've got to make sure that we move that 2 over because the absolute value has to be by itself on the left-hand side. So move that 2 over with addition. Okay, that's what we've got. We're going to go ahead and box that. And these are absolute value bars. I just like to make sure we know those are absolute value bars. We're going to be using this to check. What are my 2 equations now? My 2 equations are -3x plus 5 equals 2, or -3x plus 5 equals a -2. I'm going to go ahead and solve each of these to get our solutions. So move that 5 over. -3x now equals a -3. So x equals 1. Move the 5 over. So minus 3x equals now minus 7. Divide by a negative 3. Watch your signs. So x equals 7/3. And we're not done yet, are we? No, because they have an inequality, so that means they have to go on the number line. Which one is smaller? Well, if you can't remember, use a decimal. And what is 7/3? Okay, if you can't remember how big 7/3 is, it's 2 something. But 7/3 would be 2.3. So make sure you put them in the correct order. If you are unsure about where they go because it's a fraction, use the decimal equivalent. One place is more than enough. We have to make sure, though, that we put them in the right order. So here is 1, and here is my 7/3. Now, what is the only number that I have to check? 0. Where is 0 at? It's not in the middle anymore, is it? 0 is over here on the left. So I have to check it, and 0 is on the left. So make sure you know where 0 is. That's why I always put it where it belongs. We're going to use now the absolute value of minus 3x plus 5 is less than or equal to 2, and I'm going to check 0. So I'm going to plug my 0 in here. And 0 cancels that out, so we get a 5. And absolute value of 5, of course, is 5. And is 5 smaller than 2? True or false? This would be false, wouldn't it? Okay, so how do the signs go? If that is false, what's the middle going to be? True. And what's the other end going to be? False. Where do we shade? In the middle. Brackets or parentheses now? Square brackets. We've got one more quick topic to cover with these, and that's going to be the special cases. So we're going to look at the special cases next. But let me go ahead before I forget and pass out the sign-in sheet. But we've got about another 10 minutes worth of lecture. I'll go ahead and pass out the sign-in sheet. Okay, so what are we going to look at now? Is we're going to look at the special cases, and these are going to be when the right-hand side is negative. When the right-hand side is negative, it changes everything. We're still in 1.8. We're still looking at absolute values, and we're going to look at when the right-hand side is negative. So when the right-hand side is negative, the answer is negative to positive infinity or no solution. These are the ones that students make mistakes on more than any other. And these are the absolute easiest ones. So let's start off with something that we can just kind of look at and understand. How is this one different from all the others? Well, on all the others, the right-hand side has always been positive, hasn't it? And we would solve it, we would get our two solutions. But, bless you. But this one's a little bit different. And this goes back to what we talked about earlier today with squares. When we square a number, what happens to that value? It becomes positive. Now, a similar concept with the absolute value. The absolute value of any number is positive or 0. So we assume that this is going to be positive. Now, can positive values ever equal a negative 2? Can this ever happen? No. So this is false, and this has no solution. Why does it have no solution? Let's think about it. Anytime I take an absolute value, can I ever get out the number -2? Can that ever happen? No. Why not? Because absolute values always come out to either be positive or 0. In this case, it's positive, right? And we assume it could be 0, but it's still be the same. Positive numbers can never equal the -2, so it has no solution. Bless you. What about inequalities? Well, they work the same way. They're either going to be true or they're going to be false. Bless you. Okay, so let's look at this one. Yes, I know the weather change sometimes gets to people. It's that damp weather makes you want to sneeze. So, what are we going to do here? Well, we've solved these before, right? Okay, now this is a little bit different. We're going to move the 3 over. Nothing new. So add that 3. And now it's either going to be everything or nothing. And let's talk about why. Okay, we got our absolute value. This is negative. Oh, should be a 6, shouldn't it? My mistake. Sorry about that. Yep, should be a -6 there. My mistake. Okay, so we've got a -6 there. Now, what do we know about absolute values? They can't be negative, and they're going to give you out positive numbers, right? So, our positive numbers now, are they smaller than a -6? Is this true or is this false? Are positive numbers smaller than -6? No, they are not. So this again would be false. So this one also would have what? No solution. Let's look at 2 more. I want to do at least one of them where it's true. Let's try to solve this one. How about greater than or equal to -4? So here's another example of a special case because the right hand side is negative. Okay? This one is going to be true. So let's see why this one would be true and have an infinite number of solutions. It's true because this is positive, and our positive numbers now, are they bigger than a -4? This would be what? True. If it's true, negative to positive infinity. Because it doesn't matter what number we plug in, it's always going to be bigger than -4. Doesn't matter. We could plug in -100 for x. It's going to come out to be a positive number that is bigger than the -4. So whenever the right-hand side is negative, you then have to see if it's see if it's true or false. If it's true, it's everything. If it's false, it's nothing. Let's look at one more, and then we'll talk about our homework here. So let's do a 0 one. So let's look at this one now. So again, 0. What do we know about absolute values? What are they? Positive or 0, right? And our positive or 0 numbers, are those going to be bigger than 0? True or false? Are they bigger than 0 or equal to 0? Yes. So this again would be true. So your solution set would be negative to positive infinity. what is your homework now? So let's talk about our homework. You should be able to finish up that packet. So your homework for next time is 1.7. You should be able to do that 8 through 10. And 1.8, you should now be able to do them all. So you should be able to finish up that packet. On Tuesday, we're going to go over the practice exam. So Tuesday, I'm going to give you a practice exam. We're going to break up in groups just like we did last time. And then our second exam is going to be on Thursday. So Tuesday, we're going to come in. I'm going to give you a practice exam. I'll use the cards again to break everybody up into different groups. We'll work on that practice exam, and then your real exam will be on Thursday. If you haven't turned in your homework, make sure I get that before you leave. And if you have turned in your homework, it should be graded, and you can pick it up over here. So graded homework is over here. If you've got homework to turn in, make sure I get it. Thank you very much.